Example 5.6. In this example, I will show how to draw a loose electron dot diagram for the compound carbon tetrachloride. This is a molecular compound made up of carbon and chlorine, carbon tetrachloride. Both carbon and chlorine are nonmetals, and what I'm going to do in order to get started figuring out the Lewis electron dot diagram for this, I'm going to determine how many valence electrons are going to be available for the bonding in this compound. So what I need to do is, first of all, I'm going to figure out what atoms are present. I've got one carbon atom, 4 chlorine atoms. I'm going to look at a periodic table or a simplified periodic table, whatever you choose to use, to determine how many valence electrons carbon is providing and how many electrons each of the 4 chlorines is providing. In carbon tetrachloride, we have a carbon atom located here in the periodic table and 4 chlorine atoms. Notice that the carbon atom has 4 valence electrons, as it is in group 4A of the periodic table, and the chlorine atom has 7 valence electrons. Now, there's 4 chlorine atoms. We'll deal with that in just a minute. I now want to show you how you do the same thing with the regular periodic table. In the standard periodic table, carbon is located in group 4A. Chlorine is in group 7A. This means that each carbon atom has 4 valence electrons. Each chlorine atom has 7 valence electrons. Well, if each carbon atom has 4 valence electrons, well, there's 1 carbon atom, so that's 1 times 4, and there's 4 chlorine atoms. Now, each chlorine atom has 7 valence electrons. What I want to do is I want to determine how many valence electrons are available for bonding in this molecule. So I'm going to do a tally. 1 times 4 is 4. 4 times 7 is 28. That's a total of 32 electrons to distribute. Next, what I'm going to do is I'm going to start by identifying the central atom in the formula. Now, almost invariably, the central atom in the formula will be the first atom in the formula, which in this case is C for carbon. So I'm going to put the carbon down as the central atom, and I'm going to put 4 chlorines down around the central atom. Really, the only exception to this rule would be if your formula has hydrogen as the first atom. Then, because hydrogen is really never the central atom. Now what I'm going to do for the next step in the process, I'm going to actually draw in a chemical bond between each chlorine and the central carbon atom. Now a chemical bond is the sharing of a pair of electrons. So I'm going to do that now. I'm going to indicate on each one of these lines, that's the sharing of a pair of electrons. At this point, what I have done is I've indicated that there are 4 bonds total in this molecule, and each chlorine is bonded to the central atom, the carbon. The next step of the process is to make the outside atoms happy. Now, there's a rule known as the octet rule. And so for all atoms other than hydrogen, we want to make sure that the outer atoms have 8 electrons around them. Well, take one of the chlorines. Take this chlorine here. Right now it sees 2 electrons. It wants to have 8 in total, so I'm going to give it 6 more. And I'm just going to put those electrons around it. Now, this chlorine sees 8 electrons in total, so it's happy. Now I'm going to make sure the other chlorines feel the same way. So I'm going to give each of these chlorines 6 more electrons for a total of 8 electrons. The little dots I'm putting down represent electrons. I just want to be clear about that. Now, each of the outside atoms, each chlorine, has 8 electrons around it. What about the central atom? Well, the carbon, how many electrons does it see? Well, it sees 2, 4, 6, 8. So now there's this arrangement that's being made where there's a sharing of the valence electrons between all of the atoms in the molecular formula. What I need to do now is just check to make sure I have the right number of valence electrons in my drawing. You see, the number of valence electrons in my drawing must match the number of valence electrons that I had total in the molecule. So I'm going to do a little count. Well, I've got 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. I have 32 dots down in my drawing. I had 32 electrons to distribute, so I have a happy Lewis electron dot diagram.